Hello everyone, this is going to be our Unit 4 test review. For the first section, all we have to do is identify the special segments that are in the triangle. For part A, if you notice, there is a right angle, and these two sides are marked congruent. So this is a perpendicular bisector. In part B, if you notice the two tick marks here, that means M is a midpoint. So you're traveling from a vertex to a midpoint, which is a median. For part C, you have a right angle, and you're going from a vertex to the opposite side and making that right angle. Okay, so this is an altitude. And last but not least, in part D here, we've got two angles up top here in A that are marked congruent. So that means AD is an angle bisector. All right, number 2, you are told RS is an altitude, which means I can put a right angle here at S because an altitude goes from a vertex to the opposite side and forms a right angle. You are told angle RST, okay, so this is angle RST. Okay, so this angle right here, you are told is 6x minus 6. So that right angle we just drew is also 6x minus 6. You also know that ST is 2x plus 3, and that ES is an x minus 7. So we're going to use our right angle and the 6x minus 6 together to make our equation. Okay, so since we know that 6x minus 6 was supposed to equal 90 degrees because it's perpendicular, we can solve for x here. We can add 6. So we got 6x equals 96, and we can divide by 6. So x equals 16. Okay, now, you are also told to find the length of ET. Okay, so from E to T, that's going to be an x minus 7 plus a 2x plus 3. Okay, that's what E to T is going to equal. So ET, if I combine my like terms, is 3x minus 4. So to figure out the length of ET, I can plug in my x, which is 16. And you get that ET is 44. For number 3, we have an angle bisector. TA is an angle bisector. So that means that these two angles at T are going to be congruent if TA is the angle bisector of angle RTE. You are told that RTA, okay, R to T to A, that's this top half of the angle, is 4y minus 17. And ATE, the bottom half of the angle, is 3y minus 4. Since you know this is an angle bisector, you can set those equal to each other. 4y minus 17 equals 3y minus 4. We can subtract our 3y. We've got a y minus 17 equals a negative 4, and add the 17. So y is 13. Okay, we are told to find the measure of RTA. Okay, angle RTA, R to T to A, is this angle right here. So we can say 4y minus 17 is what we're focused on for angle RTA. And we can plug in our y. So 4 times 13 minus 17. So angle RTA is going to equal 35 degrees. Number 4, you have EY is a median. Okay, so a median goes from a vertex to the opposite side, and it's a midpoint on the opposite side. So I know that RY and YT are congruent to each other. So for part A, you are told RY is 2z minus 1, and YT is 4z minus 11. So since I know this is a median, for part A, I can set those two equal to each other. 2z minus 1 equals 4z minus 11. And then we can solve by subtracting our 2z. We got negative 1 equals 2z minus 11. We can add our 11. So we have 10 equals 2z. Divide by 2. So 5 is what z equals. In part A, they tell you to find the length of RT. Okay, so RT, that's this whole side right here. So I would be adding those together. 2z minus 1 plus the 4z minus 11. Okay, so RT, if I add those together, is 6z minus 12. So to figure out the length of RT, we can plug in our 5. So that's going to be a 30 minus 12, which means RT is 18. All right, for part B, you are told EC, so from here to here is 14, and that CY, this piece, from C to Y, is 2m minus 5. Okay, CY is the little piece, and EC is the big piece. We talked about how half of the big piece equals the small piece, right? So if I do half of the big piece, 14, it will equal the small piece, which is 2m minus 5. Okay, so we've got a 7 equals 2m minus 5. I can add my 5. So now I've got 12 equals 2m, and I can divide by 2. Okay, so 6 is what m is equal to, and that's all it asked you to do for part B, was to figure out what m was. Number 5, you are told GI is a perpendicular bisector. Okay, so we've got from G to I, we are perpendicular, and it's a bisector. So you are told EH, okay, that's this piece here, which we know that a perpendicular bisector, any point on it, like H, is going to be equidistant to the end points of the segment. So H to E and H to F are congruent to each other. So you are told EH is 16, and that H or FH is 6x minus 5. So for part A, we know those are equal, so 16 equals the 6x minus 5. We can add 5. We get 21 is equal to 6x. And we can divide by 6, and 21 divided by 6 is 3.5. Okay, so there's x. That's all they wanted us to do in part A. Okay, for part B, you are told EG is 3.2y minus 1, and FG is 2y plus 5. We know that those two pieces are equal, so for B, we can set them equal. 3.2y minus 1 equals 2y plus 5. We can subtract the 2y. We get 1.2y minus 1 equals 5. Add the 1. 1.2y equals 6. And if we divide by 1.2, 6 divided by 1.2 is 5. Okay, so y is 5. And last but not least, for part C, you are told that angle FGH is 12z. Okay, so here, FGH. So this angle right here, which we already marked as a right angle. Okay, so for part C, we can say that we are using this 90-degree angle in FGH, so it'd be 12z equals 90, and you would divide by 12. You would get z is equal to 7.5. And that's because they told us that this angle right here was 12z, which we knew was a right angle. Okay, number 6, P is the in-center of the triangle. Okay, so an in-center, what we need to know, because they're talking about PT, which is this segment, and PV, which is this segment, and asking you to find PU, which is this segment. So, thing you need to know about the in-center is that it is equidistant to the sides of the triangle. So all three of those red lines are congruent to each other. So I put little tick marks on them. So we know that PT is congruent to PV, which is also congruent to PU. Okay, so for our equation, we're told PT and PV, so we can set those equal to each other. 2x plus 4 equals 4x minus 6. We can minus the 2x. 4 equals 2x minus 6. Add 6. We have 10 equals 2x, and divide by 2. So 5 is what x equals. Now, they don't ask you to find only x. They also ask you to find the measure of PU. And we know that PT, PV, and PU all equal the same thing. So PT, if I plug in my 5, it'd be 2 times 5 plus 4. Okay, that is a 10 plus 4, that is 14. And for PV, if I plugged in the 5, it'd be 4 times 5, which is 20. And 20 minus 6 is 14. So since I know PT, PV, and PU are all the same length, that means PU is also 14. Okay, number 7, you are told point U is the centroid. Okay, so a centroid for the triangle is going to be the big piece and the small piece idea. Okay, centroids also come from medians. And so, nope, we don't need to know that. Nope, we're good. Okay, so for part A, you are told UP, this piece, is 4.2. And RU, this piece, is 2x minus 4. Okay, so we know that 2 times the small piece is going to equal the big piece. So 2 times that 4.2 is equal to the big piece, which is 2x minus 4. So this is an 8.4 equals 2x minus 4. Can add our 4. So that would be 12.4 equals 2x. Divide 2. And so we get 6.2 for x. Okay, it also asks you to find the length of RP. Okay, so R to P is the entire thing, right? Okay, we know that UP is 4.2. We know that RU is 2 times the small piece, 4.2, which is 8.4. So to figure out R to P, you just add those up, 4.2 plus 8.4, which makes 12.6 for RP. All right, for part B, you are told SQ. All right, so SQ, that's the entire thing, is 30. You are also told UQ, this piece, from here to here, is 2y plus 4. So here, I'm going to write that the whole thing is 30. If you know that the whole thing is 30, we also talked about the fact that the big piece is 2/3 of the whole thing. Okay, so here I'll write that big is 2/3 of the whole thing, and the small piece is 1/3 of the whole thing. So since they talk about the small piece here, I'm going to use this relationship, that the small piece, 2y plus 4, is 1/3 of the whole thing, which I know is 30. So we've got 2y plus 4, 1/3 of 30 is 10, and then we solve. Minus 4, 2y equals 6, and divide 2, so y is 3. Let me see. They just ask you to find the value of y. They don't want you to plug back into anything. But just in case you were wondering, if the whole thing is 30, then that means SU, that the bigger piece is going to be 20, and the small piece is going to be 10. Because remember, 2 times the small piece is the big piece. All right, you are planning to build a shopping center between towns A, B, and C. These towns are very competitive and they don't want the shopping center to be closer to one town than the other. So that means we want our point to be equidistant. Whoops, let me spell that right. Equidistant to each town. And those towns are in the vertices. Okay, so when they ask you how will you determine the location for your shopping center, we need to remember that the special center of a triangle that is equidistant to the vertices is the circumcenter. Okay, so the circumcenter is the location for this shopping center. So you want the shopping center to be at the circumcenter. Next part of the question, what will you use to find that location? Well, your circumcenter is made using perpendicular bisectors. Okay, so you want it to be the circumcenter, and you're going to find the circumcenter using perpendicular bisectors. The Parks Department is installing a circular sprinkler, a sprinkler whose spray makes the perfect circle, to water the lawn at a park that is in the shape of a triangle. It is surrounded by sidewalks. The sprinkler should be placed so that it covers as much lawn as possible without spraying the sidewalks. So the circle has to be completely inside the triangle that's made by those sidewalks. Here, if you want, I can draw you a picture here. Here's our triangular park, and we want our sprinkler to spray a circle inside of our triangle without actually hitting the sidewalks that form this triangle. Okay, that wasn't too bad. Okay, so we want our sprinkler to be spraying out inside of our triangle, but not so far that it gets onto the sidewalks. Okay, our special center that was a circle inside the triangle was the in-center. Okay? Now, this does not ask how to find the in-center. What it asks is, will the sprinkler be able to water the entire lawn? Okay? No, sprinkler can't reach the entire lawn. Okay, there are certain pieces of this triangle in the lawn, like this piece and all of this and all of this, that is not being hit by the sprinkler. Everything inside the circle is getting hit by the sprinkler, but nothing outside the circle. Okay, so your answer is no, we will not be able to reach the entire lawn. Okay, for 10, 11, and 12, you have to decide if there's enough information to determine if these are parallelograms. Okay, so number 10, you have diagonals that are marked that they bisect each other. So like this piece is congruent to this piece, and this piece is congruent to this piece. Okay, one of our properties of a parallelogram, you know what? I am going to list out those properties for you. Okay, so your first property, here, props of parallelogram. Okay, first property, opposite sides are congruent. Opposite angles are congruent. Same side interior angles are supplementary. And diagonals bisect each other. Okay, so if I look at number 10, I have diagonals bisecting each other, which is a property of a parallelogram. So I can say yes, because diagonals bisect each other. Okay, for number 11, if you look, we've got some markings on the sides, so I need to look at what information I have about my sides. For a property of a parallelogram, opposite sides are congruent. So if you look here, it's not your opposite sides that are congruent. These are the adjacent sides. Okay, so this is a no because opposite sides not congruent. Okay, this could be a kite. Because, ooh, that's not how you spell kite. Wow. Kite. Because the adjacent sides are congruent and kites are not parallelograms. Okay, for number 12, I've got my angles marked congruent, so I need to look. Property number 2 said opposite angles are congruent. Well, this angle is congruent to this angle, and this angle is congruent to this angle. Okay, so this is a yes, because opposite angles are congruent. Okay, so thinking about those same properties that I listed up top, we're going to use those properties because it says these figures are parallelograms. So we need to use those properties. Okay, first thing, if I look at these two angles that both have an X in them, these are same side interior angles, and they are supplementary, which means they add up to 180 degrees. So my equation is going to be 4x plus 80 plus the 2x minus 20 equals 180 degrees. Okay, I also know that these two angles, opposite angles, are congruent. So a second equation I'm going to have is that 2x minus 20 is equal to 4y plus 8. Now I cannot solve that one yet because it has two variables in it. So I'm going to focus on my supplementary angles first. If I combine my like terms, we've got 6x plus 60 equals 180. We can subtract the 60. Got 6x equals 120 and divide by 6. So x is 20. Okay, I'm going to use that now to solve this other equation. We've got a 2. We can plug in our 20. Oops. Plug in our 20. Then minus 20 equals 4y plus 8. Okay, 2 times 20 is 40, and 40 minus 20 is 20. And we can subtract our 8. That is 12 equals 4y, and divide by 4. So 12 divided by 4 is 3, and that's what y is. Okay, now just to make sure, it says find the value of the variables. That's all we had to do for that one. Okay, for number 14, I have side lengths marked, and in a parallelogram, opposite sides are congruent. Okay, so this side is equal to this side, and this side is equal to this side. Okay, so I can set up two equations. First one I can set up is that 2m plus 8 equals 3m minus 1. My second equation that I can set up is that s plus 1 equals the 5m minus 2. I can't solve this blue equation yet because it's got two variables in it. So I'm going to focus on this red equation. I'm going to subtract our 2m. We've got 8 equals m minus 1, and add the 1. Okay, so we've got 9 is what m is. Now I can take that m and plug it into my blue equation over here. So we got s plus 1 equals 5 times our 9 minus 2. So we've got an s plus 1 equals 5 times 9 is 45, minus 2 is 43. And we're going to subtract the 1. So s is 42. Okay, next section. Identify the figure based on the features, find the value of the variables, and all indicated side or angle measures. Okay, so this first figure is a kite, and that is because we have adjacent sides being marked congruent. Okay, so I've got one equation I can set up here that m plus 3 is equal to 3m minus 5. I also have a second equation I can set up because of these two sides, and it is m minus 2t is equal to t plus 9. So in our green equation here, we have the same variable, so we're going to solve that first. We're going to subtract our m. So we've got 3 equals 2m minus 5. We can add our 5. So 8 equals 2m. And divide by 2. So 4 is equal to m. Whoops. I divided by 2. So 4 is m. All right, now that I know my m is 4, I can plug it in to my equation up here. So 4 minus 2t equals t plus 9. We can subtract. Nope, we want to add 2t. It's always good to have a positive variable. So we've got 4 is now equal to 3t plus 9. We can subtract 9. So 4 minus 9 is a negative 5 equals 3t. And then we divide by 3. Okay, so we have a negative 5/3 for our t value. Okay, now in the directions, they want you to find the value of the variables, but then they also want you to find all of the sides or the angle measures. Okay, so in my figure here, if I do m plus 3, 4 plus 3 is 7. So this side is 7, which means this side should be 7. And 3 times 4 is 12, 12 minus 5, that is 7. Okay, in the other side, if I do t plus 9, so I'm doing negative 5/3 plus 9. If you type that into your calculator, you end up with 22/3, which means this side is also 22/3. Okay, for number 16, this is a rhombus. Okay, I know that because of these 4 tick marks that are marking all 4 sides. Okay, in a rhombus, the diagonal bisects the opposite angles. Okay, so if this angle is labeled with an X and a Y, that means that this angle is also going to be labeled with an X and a y, because those diagonals or that diagonal is bisecting or cutting that angle in half, which means if it's getting cut in half, the x and y are going to be the exact same number. Okay, so if I focus on this triangle, okay, this is an isosceles triangle. Okay, so I'm going to draw a little picture here. Okay, I've got 110 up top, my congruent sides, and then I've got my congruent angles, which are both x's. If I do 180 minus 110, because there's 180 degrees in a triangle, right? Triangle equals 180 degrees, okay? So 180 minus 110 gives me 70. And then I need to split that 70 equally between my x's. So I'm going to divide it by 2, which is 35. So that means x is 35. Well, if x and y are equal, then y is also 35. Okay, we are told to find the angle measures. So all I have to do is label that this one is 35 degrees and this one is 35 degrees. Okay, in this one, I don't have to name the figure. They tell me it's a rectangle. So I'm going to draw my rectangle. We've got A, B, C, D. We have diagonals AC and BD. They intersect at point E. Okay, you are told that AE is 3x plus 37. Let me see if I can write that on here. Okay, 3x plus 37. You are told CE is 6x plus 10. And BD, okay, so that's the entire diagonal, BD, is 3x plus 3y plus 41. Okay, in a rectangle, the diagonals bisect each other, and the diagonals are congruent. So I know that this piece is congruent to this piece, which is congruent to this piece, which is congruent to this piece, okay? Diagonals bisect, they are also congruent. So for my first equation, I can say 3x plus 37 equals the 6x plus 10. So I can go ahead and solve that. I can minus my 3x, and I've got 37 equals 3x plus 10 minus 10 is 27 equals 3x, and divide by 3. Okay, so I know that 9 is what x is. Okay, for the fact that my diagonals are congruent to each other, I know that from A to C is going to be congruent to B to D. Okay, now my A to C is going to be these two pieces added up, right? So we've got 3x plus 37 plus the 6x plus 10 is what AC is. And then in the problem, they told us that BD is 3x plus 3y plus 41. 3x plus 3y. Hold on, let me rewrite that. Okay, 3x plus 3y plus 41. Okay, let me simplify on my left side here. This is 9x plus 47 equals 3x plus 3y plus 41. Now the fabulous thing is, I know what x is, so I can plug it in. We've got 9, my x is 9, plus 47 equals 3 times 9 plus 3y plus 41. Okay, so 9 times 9 is 81, and 81 plus 47 is 128. Okay, 3 times 9 plus 41, this side is going to be 3y plus 68. Then we can subtract our 68. And 128 minus 68 is 60 equals 3y. And so we can divide by 3. Okay, so 20 is what y is equal to. Now remember, they did tell me to find all segment or angle measures. Okay, so I'm just going to make a list here. The 3 segments that they gave me were AE, CE, and BD. So those are the 3 segments that I am going to find the value of. So AE, we were told, is 3 times x plus 37. So 3 times x plus 37. Okay, so 3 times 9 plus 37 gives you 64. Okay, you know that AE and CE are the same, so CE is also going to be 64. And then BD, if I plug in my x and my y, 3 times my x, which is 9, plus 3 times my y, which is 20, and then plus 41, BD ends up being 128, which is also what 64 plus 64 is. All right, next we have an isosceles trapezoid. And I know it's isosceles because these 2 sides are marked congruent. Okay, in an isosceles trapezoid, same side interior angles are supplementary. Okay, so that means they're going to add up to 180 degrees. Okay, these 2 are my same side interior angles. So I can say that 4x plus the 6x plus 20 adds up to 180. So we've got 10x plus 20 equals 180. We can subtract our 20. We have 10x equals 160 and divide by 10. So x is 16. Okay, for the y value, okay, we know that base angles are congruent, okay? So these 2 angles, which are my base angles, are congruent to each other. Okay, so for this equation, I'm going to write it down here. We can say that our 6x plus 20 is equal to our y. Now the good thing is, I already know what x is, so I can plug it in. 6 times 16 plus 20 equals y, and 6 times 16 plus 20 is 116. So that's what the y value is. Okay, remember we are supposed to find the angle measures. Okay, so we know this angle, y, is 116 degrees, which means this angle is 116 degrees. And if I plug in my x value, 4 times 16 that means this angle is 64 degrees. Which means the other base angle in the bottom right corner would also be 64 degrees. Number 19, the only markings on this picture that can tell me what it is are these arrows, and those arrows mean parallel. So this is just a parallelogram. Okay, and if you look, we are told some stuff about the diagonals, and in a parallelogram, the diagonals bisect each other. Okay, so that means this piece is congruent to this piece, and this piece is congruent to this piece. But we do not know that the diagonals are equal to each other. That's why I put a single tick mark on two of them and a double tick mark on the other two. Okay, but I do know that 4x minus 2 will equal 3y minus 1. And here I'm actually going to change colors, that these two would be 3y minus 3 equals 3x. So what I'm going to have to do here is use substitution, because both of my equations have both variables in it. Okay, so if I divide 3 here, y minus 1 is what x is going to equal. So I can take what x equals and plug it into the other equation. So we've got 4 times our y minus 1 minus 2 equals 3y minus 1. So if I distribute this 4, we've got 4y minus 4 minus 2 equals 3y minus 1. 4y minus 6 equals 3y minus 1. And then we can start solving. I'm going to subtract the 3y. So that leaves us with y minus 6 equals a negative 1. And add the 6. So that is y is 5. Now I can take what y equals and plug it into my equation for x. Okay, so if I use this blue equation here and I say my 5 is getting plugged in, it will say minus 1 equals x, so 4 is what x is. Okay, we have the value of both variables. Now we just need to plug in and get our segment lengths. Okay, so for 3 times x, okay, our x is 4, so 3 times x is 12, which means this other side of the diagonal is also 12. And if I plug in my y, I know that my y value was 5. So if I plug in 3 times 5 minus 1, that's a 15 minus 1. So this segment is 14, which means this segment is 14. Okay, for number 20 here, this is going to be a kite, because you are told that these two pieces are equal and these two pieces are equal. Okay, for my equations though, I have to look at where the information is placed, and they are placed in angles. So the thing I know about angles in a kite is that you have one pair of congruent angles, okay, which are these two, and then you have one pair of bisected angles. Okay, so we've got these two are going to be equal, which means if the top one is y minus 9, so is the bottom one. and then this one is equal to this one. You know what? I should have used here. I'll do this. I know that these two angles are congruent, so I'll just put 3 arcs on those. That way I have 1 arc, 2 arcs, and 3 arcs. Okay, anyways, if this angle is y, then I know that this angle is also y. Okay, for my first equation, I'm going to focus on those angles that are congruent. Okay, so my congruent angles are going to be the green ones, which are 4x plus 13, which is equal to 5x minus 15. I can subtract my 4x, so 13 equals x minus 15, and add 15. So 28 is what x is. Now what I'm going to do is focus on one of these triangles. I'll just focus on this one on the bottom here. Okay, so I've got a triangle. I've got a y in this corner. I've got a y minus 9 in this corner. And then in this angle, we've got 5x minus 15. Now the good thing is I already know what x is. Okay, so if I do 5 times 28 minus 15, that comes out to 125. Okay, so there are 125 degrees in this corner. Then we've got y in one corner and y minus 9 in the other corner. And you know that triangles equal 180 degrees, right? So if I say y minus 9 plus the y plus the 125, all of those added together equal 180 degrees. So if I combine like terms, I've got 2y plus 116 equals 180. And then I can start solving by subtracting my 116. We've got 2y equals 64, and then divide by 2, so y is 32. Okay, we also have to find out those angle measures. Okay, so for this angle that was labeled with y minus 9, okay, our y value was 32, so we're doing 32 minus 9, which is 23 degrees. Okay, and that's for this angle right here. Okay, for this top angle up here, if I do 4 times my x value, so 4 times 28 plus 13, that equals 125 degrees. That's for this angle. Which means this one down here is also 125 degrees because they are congruent. And then my y value was 32, so this angle right here is 32 degrees. Those were my labeled angles that I needed to find the measure of. Okay, in number 21, we have 4 right angles, and my picture I think actually got stretched a little bit because that is supposed to look like a square. There we go. Looks a little better. All right, so like I was saying, this is a square, and I know that because of my 4 right angles, and those sides are congruent along with our diagonals are congruent. Okay, so first of all, our diagonals are kind of what's important here because they're drawn in the picture. The diagonals bisect opposite angles. So that means that each of these right angles is being cut in half. Okay, so this side is going to equal 45 degrees. this side is 45. This one's 45 and this one's 45. This one's 45 and this one's 45. This one's 45 and this one's 45. So I actually already have a couple of the angle measures that I need for after I get my variables. Okay, this one is 45. Let's see, the other angle that's marked is the 3x plus 18, and that's pointing at this angle. Okay, so to figure out x, I can say 5x is 45 degrees. Divide by 5, so x is 9. Okay, I also know that the diagonals bisect each other. Okay, so this piece is going to be congruent to this piece, which means 2y is equal to 10. So we can divide by 2, and y is 5. All right, so that means that this piece is 10 as well. Let me rewrite that, you can't really read it. Okay, so I had a tick mark here. Let me get my skinnier line. This segment is also 10. All right, for number 22, this is a trapezoid. Okay, it is not isosceles because if you look at side AM, it has one tick mark on each piece, and then side RC has 2 tick marks on each piece. So they are not the same length. Okay, but we do have a mid-segment here. Okay, so here, I'm going to highlight it in blue, midpoint to midpoint, and I'm going to write my formula out. Okay, it was the mid-segment. I'm going to write it below the figure, I think. The mid-segment equals 1/2 of base 1 plus base 2. So we can say this is base 1, and this is base 2, and then we just plug in. So our mid-segment is 3x. 1/2 base 1 is 2x minus 12 plus base 2, which is 5x plus 4. 3x equals 1/2. We can combine like terms. This is 7x minus 8 and distribute our 1/2. 3x equals 3.5x minus 4. So we can subtract our 3.5x. Okay, which means I have a negative 0.5x equals a negative 4, and we can divide by a negative 0.5. So x is 8. Okay, they tell you to find each segment length. Okay, so 3 times 8 for my mid-segment means my mid-segment is 24. 2 times 8 minus 12, that is a 16 minus 12, so my base 1 has a length of 4. And from A to C, if I say 5 times 8, that's 40 plus 4. My bottom base here is 44. Okay, in number 23, we've got all sides marked congruent, which means this is a rhombus. Okay, and that's because all 3 sides, or not all 3, all 4 sides are marked congruent. Okay, in a rhombus, since we need to know about our diagonals because they're drawn in the picture, I'm going to write out what we know about our diagonals. First thing is that your diagonals are perpendicular. Okay, so that means at the center here, I have right angles. but I just need to focus on that one right angle that's labeled with a 6x, because I can say 6x equals 90 degrees and divide by 6. So x is 15. Okay, the other thing I need to know about my diagonals is that diagonals bisect opposite angles. Okay, so that means that this angle is congruent to this angle, and this angle is congruent to this angle. So I can transfer that 2x minus 1 to all 3 of those other locations. So this is a 2x minus 1, this is a 2x minus 1, and this is a 2x minus 1. Okay, for my y, I know that this angle is congruent to this angle, so this is y, and this angle, y, congruent to this angle, y. All right, so let's focus on any one of these triangles. It really doesn't matter which one we focus on. So I'm just going to pick this one, since that's where our original y was located. Okay, so if I focus, I've got a right triangle, I've got a right angle here. This top corner is the 2x minus 1, and the bottom corner is the y. Now I know what x is, so I can say this is 2 times my 15 minus 1. So we've got 30 minus 1, which means this top corner here is a 29. So if I know that triangles equal 180 degrees, I can say 29 plus my right angle 90 plus the y that I'm trying to find all add up to 180. Okay, so we've got 29 plus 90 makes 119 plus y equals 180. We can subtract our 119. So y is 61. Okay, so all the corners that I need to find y, which is 61 degrees. I need to find this corner because it was labeled, so 2 times 15, which is 30, minus 1 is 29 degrees. And then this angle, I know is a right angle, so it's going to be 90 degrees. Okay, so those are my 3 labeled angles that I needed to find the measure of. Okay. Our next shape here is a rectangle, and that's because if you look, the diagonals, they're bisecting each other and they're congruent. So this is our rectangle, and you need to focus on the fact that a rectangle is also a parallelogram because these sides are parallel, correct? And I'm going to focus on this line cutting through them. We need to know that alternate interior angles are congruent. So I know there is a 3x in the top left corner, which means I can transfer that 3x here because they are alternate interior angles. Now this x plus 2 has an arrow. This x plus 2 is actually here. So if that x plus 2 is in that angle, that means this angle is also x plus 2. And since this is a rectangle, I know that we have a right angle here. So I can say that my 3x plus the x plus 2 are supposed to add up to 90 degrees. So 4x plus 2 equals 90. I can subtract the 2. 4x equals 88 and divide by 4. So x is 22. Okay, we are told to find the measure of those angles. Okay, so 3x, that is this angle, 3 times 22 is 66 degrees. And this angle, the x plus 2, 22 plus 2 makes 24 degrees. Okay, in number 25, this is an isosceles trapezoid. And I know it's isosceles because of these tick marks here and here. Okay, in an isosceles trapezoid, we have to talk about the diagonals, okay, and your diagonals are congruent in an isosceles trapezoid. So we know that AC is going to be congruent to DB, or in this case, I guess I'll call it BD since that's what the problem called it. Okay, and since they are congruent to each other, we can plug in. We've got 7x minus 15 is equal to 4x plus 15. We can subtract 4x. We get 3x minus 15 equals 15. Add 15. So we now have 3x equals 30. Divide by 3. So x is 10. Okay, so we found x. Now we just need to find those diagonal lengths. Okay, so AC, if I plug in, we've got 7 times our x, which is 10, and then minus 15. So AC is 70 minus 15, which is 55. And then BD is supposed to be the same length, so it's also 55. Okay, number 26. Oh, buddy, this is supposed to look like a square, which means I need to fix my picture. It got skewed a little bit here. Okay, here we go. Looks a little bit more like a square. Let me just move these. Here we go. All right. So our square has 4 right angles and all sides are marked congruent. Okay, so I can say that 3x minus 14 is equal to y because these two sides are marked congruent. But since that has 2 variables in it, I can't do anything with it yet. Okay, notice the diagonals in this square are drawn, and so we need to talk about the fact that our diagonals bisect each other. So I'm going to set up an equation based on that, because if they bisect each other, I know that these two pieces are congruent. So I can say that 2x minus 1, you know what? Hold on. I can label this with a 2x minus 1 as well. Hold on, let me rewrite that. Now, since they tell me that DB is 5x minus 10, I need to focus on the fact that DB is the entire diagonal. So something else about the diagonals in a square is the diagonals are congruent. So that means that AC is congruent to DB. So to figure out what AC is, I can add up the two pieces of A to C, which would be 2x minus 1 plus another 2x minus 1, which will equal DB, which I just underlined, which is 5x minus 10. If I combine like terms, I've got 4x minus 2 equals 5x minus 10. I can subtract my 4x, and I've got negative 2 equals x minus 10. I can add the 10. And so I know that x is 8. So now that I have x is 8, I can plug it into my green equation over here to figure out y. So we've got a 3 times our x value 8 minus the 14 equals y. So we've got 24 minus 14, which means 10 is what y equals. Okay, we are told to find our segment lengths. Okay, so if I plug in up top here, 3x minus 14, 3 times 8 is 24, and 24 minus 14 is 10. Well, this is a square, and all sides are equal. So over here on the right where it says y, hey look, we know y is 10. So we know we got our variables correct since both of these sides ended up equaling 10. Okay, you are also told to find dB, so I'll just plug into that. We've got 5 times our 8, which is going to be 40, minus 10, which is 30. Okay, so that's dB is 30. And then on AE, we've got 2 times x minus 1. 2 times 8 is 16, minus 1 is 15. Okay, so from A to E is 15. All right, decide if the statement is always, sometimes, or never true. Okay, a kite is a parallelogram. Yeah, that is never true. Okay, because a kite doesn't have opposite sides parallel. Okay, because remember a kite looks like this, and you've got adjacent sides that are congruent, but none of them are parallel. All right, next one. A square is a parallelogram, a rhombus, and a rectangle. I'm going to remind you that in our notes, when we started talking about quadrilaterals, we had a picture. Okay, and it started out with just a generic quadrilateral. Here, I really don't want this to look like a kite, but it kind of seems like that's what I'm good at drawing. Okay, random quadrilateral here. Oh well. Okay, so yeah. There we go. That looks like just a generic quadrilateral. Okay, so we had a quadrilateral up top, and it had 3 branches. The first branch went to a kite. The second branch went to a trapezoid and to an isosceles trapezoid. Okay, and then we had this third branch, which had a parallelogram. Okay, which has opposite sides parallel here, so I'll put my little arrows. That parallelogram led to a rhombus, which has all four sides congruent, and a rectangle, which has the four right angles here and opposite sides congruent. Okay, so this is rhombus and rectangle. And then those led to a square. And we talked briefly about how you can move backwards through this chart, like start at the end, for instance, if I'm sitting on square, and I can say a square is a rhombus, it is also a rectangle, and it's also a parallelogram. So the answer for this second one is going to be always, oh goodness, always. A square is a parallelogram, it's also a rhombus, and it's a rectangle. Okay, for number 29, the base angles of an isosceles trapezoid are supplementary. Okay, that's going to be a never, because we know that the base angles in an isosceles trapezoid are congruent. Okay, so if you had a picture of an isosceles trapezoid, this angle is congruent to this angle is congruent to this angle. So the base angles are congruent, they're not supplementary. Okay, for number 30, the adjacent angles of a rectangle are congruent and supplementary. So let me draw a rectangle. We know rectangles have right angles. Okay, so these two angles, they are adjacent, right? It says these adjacent angles are congruent. Well, yes, if they're congruent, 90 is congruent to 90. So check mark to congruent. Now supplementary. If I do 90 plus 90, that does equal 180. So check mark to supplementary as well, which means this is going to be always true. And for number 31, the diagonals of a parallelogram bisect both pairs of opposite angles. Okay, so the important part here is bisect opposite angles. We have two figures, and that's a rhombus and a square. Rhombus and square, that this is true for. However, those are not our only parallelograms. If you look, we have one more parallelogram to talk about, and that's a rectangle. Okay, in a rectangle, that's false. A rectangle does not have opposite angles bisected. Okay, so that means this is a sometimes. If I could spell sometimes. Sometimes. Okay, so sometimes for this one, always for this one, never, always, and never.